physicist. He's trained in climate modeling, and you have spent a few years. He knows better. Well, how is it?
The metaphysics had a center. I will say.
Okay, you will say it. Okay, thank you. Thank you very much.
Thank you very much, Caroline. Thank you very much for everyone to be still around. The room was a little bit more crowded earlier today, but that should be fine. So yes, Caroline was brave enough to give this task of synthesis to a physicist. But maybe it's a nice thing to try. I mean, we all face, obviously, an uncertain future, and multidisciplinarity will be needed to tackle this future, and I will try to give a little bit my view and my feeling of what I have learned today in the hope that it can be a bit useful. So today we spoke a lot about those guys, maybe not those in particular, but farmers, and agriculture is obviously at the center of the issues that concern us, whether we are concerned about climate change or about biodiversity. But perhaps we spoke a little bit about this guy as well, who is in Afghanistan and maybe worries about his future, or maybe this lady who is interested in farming, but also implement it. If you see the newspaper from which this picture was taken from, she's interested also in implementing technological solution for sustainable farming. So I live not very far from here, and I tend to buy my vegetables to a local farmer, and he's a nice guy. He always speaks a lot about weather, and that's quite obvious when you're a farmer, because you care a lot about whether it will rain tomorrow or not, and much more than us. I mean, we are just concerned about having a raincoat, but he really is concerned about basically making a living. And so farmers are people who have to anticipate every day. They have to basically think about coming weather. They have to think about crop yields. They have to think maybe about the price they will sell their culture. So they do like us. But anticipating, I think, has a special meaning when you're a farmer. So what is anticipating in a certain sense? It's essentially decoding information. It's reading signals. I mean, we have this idea of the farmer, or maybe the fisherman, who reads the weather. I mean, today it's a bit foggy, so tomorrow it will be fine, or maybe not. So they are basically decoding information to make decisions. Make important decisions about themselves. And basically that might be a definition for living organisms. Whether you're a bacteria or farmer or a university professor, what you're doing every day is to read, to survey your environment, and decode what you read. How does it work in practice? We have somehow a decision matrix. You can see it this way. If you have a bacteria, maybe it's your genome and the environment in which this genome is expressed, and which makes a connection between the signals which are taken from the outside and the action, the metabolism that is being produced. Maybe if you're a university professor, it's a little bit more complicated, but in a certain sense, it's the same idea. You're reading signals, maybe you're reading books, or you're reading papers, your emails, and because of your training, what you have learned, you have all these connections in your brain, and also the way your genomes works to make all these things happen, and then you take decisions. So farmers are taking these decisions every way. They depend on weather, and they're also concerned about climate change. Last summer, there was this tweet. It's in French. Many of you can read French, but I will translate it for you. I don't know, by the way, the phrase in English to speak about those farmers who cultivate vineyards, les vignerons. Does anyone know the translation? Wine growers, anyway. So last summer there was, as you know, obviously a very serious heat wave in France with temperatures which had not been recorded before, and a lot of these vines were just burnt, destroyed. And what these vine growers said is, what happened today, it's a warning signal, essentially. So it's not, she has a blog, and she says, I'm not speaking like a vine grower, but I'm speaking as someone who basically has seen something. So she was sensitive to basically a signal, and in the context of climate change, she was reading something that was basically prompting action, at least prompting worry, and probably prompting action. So anticipating is not just us, it's not just vine growers, it's not just farmers, nature does it. And last year I read this quite interesting study about the Amazon rainforest. In fact, it's a study published 2 years ago. And basically what they do, they installed, these flux towers there. These are this equipment which is made to monitor the heat and the water vapor fluxes. And they realize something maybe a bit surprising when you think of, if you don't think about it too much, it's quite surprising. So there is a large part of the Amazon which is submitted to a seasonal cycle, and basically have a rain season and a dry season. And what this study showed is that the trees are actually anticipating the rain season. So what they do is that they accelerate their metabolism and increase their evapotranspiration before the rain actually comes. So basically they make themselves ready and even take a little bit of advance, if they can, by pumping the water table. And basically, that makes them, in a certain sense, strategic. Well, maybe it's surprising, but if we live in Europe, we see something similar every year. We are now in this season of the year where the trees are losing their leaves. And what they're actually doing is, in a certain sense, anticipating the cold season. So trees do that, farmers do that, and sometimes yet we are in crisis. So what's the crisis in a sense? The crisis is when your anticipating action becomes essentially, maybe biologists would say, maladaptive. It makes you take the wrong decisions. So in a certain way, all your decision rules, and we are starting now to speak about the day, all your decision rules, the way you interpret the signals makes you take wrong decisions and basically may aggravate the situation. If you take one of those oak trees that we have and cheat it by basically fooling it with the wrong daylight signals, it will not lose its leaves on time and maybe will undergo a lot of damage. And so being in this kind of crisis and being in this kind of the wrong decision setup is always extremely costly, because obviously all these decisions that you have to take while having basically not have had the right reading guide makes you take urgent action, and there is always a cost in taking very urgent action compared to the cost of taking a good anticipatory decision. So now coming back to the talks of the day, maybe if there is one slide that really impressed me and made me think and maybe a bit hopeless, was that slide that Jean-Pascal Van Ypersel showed. It was a copy-paste from a newspaper article in The Conversation by a certain Knorr. And you could see the growth of emissions. And underlined were all the protocols, you remember, the Kyoto Protocol, the Paris Agreement, and basically this has no impact. So if we compare ourselves to this, I didn't want to show this slide, to this lady, we are scientists. Many of us, at least in this room, do science as a profession. You are researchers. You are paid by the citizens to do science. And we did something that was not so common decades ago, is that we take the risk of making predictions. So whether you are a climate scientist or whether you are a specialist of the biodiversity, there was this talk earlier this morning by, I'm very bad at names, and now I cannot read my own reading anymore. I'm sorry, I forgot the first name, Urban. what is your first name? Mark. Okay, so you were arguing basically for mechanistic models for forecasting. I mean, climate scientists, we are very cautious with words. I mean, I say we, but I don't like it. In fact, we tend to speak of projections, but projections, I dislike it because it's a mathematical operation, by the way. But okay, we are a bit careful about the way we want to do it because it's like a sin. And we are supposed to describe nature, but what we actually do is forecasting, prediction, using models, by the way, mechanistic models. And we want it to be useful information. And that's also the reason why scientists, under obviously the framework of the United Nations, started to organize themselves and having this IPBES for biodiversity, this IPCC for climate. So basically there is a whole community of scientists using their ways of working and their ethos, their way of basically deciding that an information is true versus something is bad. Well, basically making a delineation between good science and bad science. Let's do it this way. I speak under the control of philosophers in this room, but okay, I take this risk of using these words. And we are willing to deliver trustful and reliable information. But in a certain sense, it's a very hard problem to close the loop and make it such that this information actually has impact on a global behavior. And what is a global behavior? No one knows. What is the behavior of the global society? No one knows. And even this word, Anthropocene, has been criticized for the very reason that there is not something like a global human community, even though a fraction of the human population is actually having the largest impact. So, where is the hope? And the hope is where these local loops can actually happen. And so it was, in a way, it was quite joyful also to see successful experiments. So we had this example that Patrick Meffroy explained about this rice plantation and rice paddling in Vietnam. And this is an example where you can actually close the loop between science, values, which is not quite a domain of science. I mean, we are not supposed to tell people what to do. We are supposed basically to explain possible futures. And at a certain level, you have this hope to change the decision models. All these lockings that have been enumerated by Philippe in the last talk, I mean, are things that we are all concerned with, and that, by the way, generates sometimes frustration because we all see, all individually, all in this room, we see that we have huge impacts, but we are also in these locked-ins. And in certain occasions, it can work. You can actually have change that actually changes also the prediction model that people have in themselves. And this is what ultimately generates resilience and empowerment and the possibility to face the future with much more trust and confidence. Now, having basically set this picture, I want to maybe, how to say, to take this posture of the physicist and see how it can be contrasted with the biologist. So if you talk to, I was trained as a physicist myself, which implies having learned to model the climate as a physicist do it. So the concepts, the ontology in a sense that you use, are the words energy, force, mass, flux, and unsurprisingly, all climate models I know about are using this framework. So you know that people started to worry about climate change in the 70s, in the 80s, and in 1990, Margaret Thatcher in the UK, she decided that her country, probably with her money, had to have the strategic capacity to predict climate change. And so that's the reason why she funded well, my English is bad enough to have difficulties to make the difference between these two words, but she gave the money, so she funded and she helped to found the Hadley Center. I mean, George Hadley was an English meteorologist. So there was a strategic goal. A country must have the strategic capacity to know what will happen with climate change. And it's interesting, by the way, because I used to work for the Hadley Center, and there was a little allusion today about climato-skepticism, all these people who say that climate change is a hoax. And it was actually the job of the Hadley Center to take all these informations seriously and check what actually is fake and what is true. And I could really see that even most trenchest proposals were actually looked at seriously, and obviously to conclude generally very quickly that it's completely nonsense. That's interesting to see that the Hadley Center, the Pentagon, and anything that has actually a strategic capacity is actually acknowledging climate change as a very serious threat. I think it's enough to convince most of the public that actually those people who say that we are just bad scientists in making jokes about climate change have no, I mean, it's complete nonsense. Maybe in the biodiversity sector, you will face similar debates. I mean, climate scientists have had now a 30-year history, basically, of very close fights with people who are called now merchants of doubt. I mean, you will have your doses too, and that has made us actually extremely careful about the vocabulary and the way we formulate reports and communication to the public. But coming back to that, so most physicists, most climate models are actually made by physicists using this language. And it was quite refreshing to hear, for example, today, and I still have to read my notes with names, and sorry, I'm getting rubbish now. That's there. Close. Birkhofer, who says, I don't like indices, or I hate, you said, I hate indices. It's cool. So that's this idea that you actually a bit careful with compressing reality to a small numbers, and you are obviously right. So on that point, climate scientists maybe are a little bit at an advantage because they know that CO2 is very important quantity, and you can monitor that one. But all this risk of leakage that Patrick mentioned is that if you focus too much on one thing, then obviously you are simplifying reality and you are taking wrong decisions. So in the sector of biodiversity, you have to introduce all these words that we physicists are not familiar with. You have to introduce the word function, but not in the sense of mathematical function, but in the sense of ecosystem function. You have to introduce the word signals. You have to introduce the words evolution. And all of this, of course, is part of your language of biologists. And you will do that basically to build narratives. I didn't read the full 1.5 degree report that Jean-Pascal Van Ypersel mentioned today. But so it was a discovery for me to read that actually they use this thing. They are using narratives. So what they're actually doing now is to say in scenario one, here is what will happen, not just as a graphic, but as a set of sentences. And obviously, it's something that most scientists would consider as risky, but at the same time, which is extremely effective in communication. What I understood today is that in biodiversity issues, more than any other, let's call them hard science, you will have to use these narratives. Because the world is heavily multifaceted. The world that you see is more complex than the world that we see in a certain sense. And so narratives will be a crucial aspect of what you are writing in this IPBES report, in the way you communicate, and obviously the challenge will be to build these narratives with a very accurate semantics, so choosing all these words very carefully, making sure they have a traceable meaning, and I bet that will be a huge task. So, in conclusion, I think it's time, because everyone is tired, including the video projector. We are in a crisis time. We are in an urgent time where we actually have to forecast the future, and we know that we will not be able to forecast it accurately. So our job is to show what are the possible futures, We have to formulate in a way which is semantically extremely accurate. We cannot make accurate predictions, but the way we express our predictions has to be extremely accurate. And that is really a task for the scientist. And at the same time, we'll have to collaborate constantly with the sociologists, with philosophers, maybe with psychologists, because we don't have to say that we have to close the loop to the policy making, but we feel that it's something that should be done anyway. And so connecting these possible futures with a way to actually let the societies to behave as anticipatory system is, as I believe, the biggest challenge of the decade to come. Thank you very much.
You successfully managed to reach this challenge, to summarize interestingly and very inspiringly this day.
I could not pronounce them, so there was Tesha Chamke, and I had to do it a few times.
So you can.
But I'm sure you understood that I was also mentioning your work.
Thank you very much. Well done. And so I would like to close the day with just a few words. Now that you get the proper information, please just spread it, make up your own mind, and start communicate. It's very, very important now that we are more and more communicating the real data and not the fake information. And to help you with this, I think I obtained the agreement of all the speakers to put a PDF of the presentations on the website. And if the recording works, we also will have a video of the whole day. And this will be also on YouTube and everything after agreement by the invited speakers. So then in a week time, perhaps you would receive an email stating that this information is now available. So spread it further then. Thank you very much.
Long day.